Okay, so the second part says determine the probability of getting two tails and one head in any order. So we want, or we're looking for the event, you can call it A, where we have two tails and one head. And that will be, if we look for two tails, here we have two tails and one head. So it can either be TT, H, so the first two are tails and then we have a head, or we can have a head and then tails and tails. So head, one head, and then tail and tail for the second and third. Or we could also have tail, head, tail. So like this, tail, head, and tail, which is also two tails and one head. So that was tail, head, tail. And these should be all the different combinations you can have. Yeah, and this will be 3 out of the possible how many? 1, 2, 3, 4, 5, 6, 7, 8. There are 8 different combinations. Maybe I can write them out here. So the first one is HHH, then this one is HHT, this one is HTH, this one is HTT, and then we have THH, and then we have THT, and then TTH, and then TTT, like so. So these are all the different combinations, and what's good about it is that they all have an equal likelihood of occurring. So we don't need to be too concerned about multiplying the probabilities, which is what we would have needed to do. But since our sample space consists of all of this, this is our sample space. This is our entire possibility of events, and there are 8 of them, all with an equal likelihood of it occurring, which means the probability that A occurs would be the number that's in A over the number that's in S, the sample space is. And then in A, we have 3, and in the total sample space, we have 8. So our answer would be 3 over 8.